So today we're going to talk about sampling distributions. So these are basically different ways of sampling. When a survey is used to gather data, it's important to consider how the samples is selected for the survey. So if sampling method is biased, the survey will not obviously accurately reflect the population. So most national polls that are reported in the news are conducted using careful sampling methods in order to minimize bias. So other polls, such as those where people phone in to express their opinion, are not usually reliable as a reflection of the general population. So these are our different types here. So remember that a random sample is one that involves chance. 6 different types of samples are shown below. So I'm going to scroll up a little bit here so we can get them all. Well, we won't be able to get them all on the screen at the same time, but at least close. So first is the simple random sample. This is where members are chosen using a method that gives everyone an equally likely chance of being selected. So an example of this would be all the students, we'll say at Archer High School, all students' names at Archer High School are in a box, and 100 were drawn out. So that is what we would call just a simple random sample. The next one's a systematic sample. So members are chosen using a pattern, such as selecting every other person, or I'll give you an example, every 10th person. So normally when I'm looking at this, I look for a number. So our next one is stratified samples. So this is a population that's first divided into groups, and then the members are randomly chosen from each group. So there's some key words here. So we got divided into groups, right? And then we've got chosen from each group, okay? From each group. Okay, so this one's like we would take different classes. So we would do the 9th grade class, and then the 10th grade class, 11th grade, and 12th grade, and then we would take like maybe 100 from each class, and we would survey them. 100 from each class. Okay? Now the cluster is a little bit different. The clusters, again, with the cluster, we're going to divide, first divide it into groups again, but this time a sample of the group is randomly chosen. So one of the groups is chosen, and all the members of that group, wow, I don't know what happened there. All the members of that group then respond. Okay, so that would be like, again, we would break it up into groups, 9th, 10th, 11th, and 12th, and maybe we would choose the 9th grade only, and we would survey all 9th graders. Okay? So that's an example of a cluster. Then convenience. Convenience, our members are chosen because they are easily accessible. So this would be like, for example, I just chose my students. So Coach Jones classes. Okay, and that's just because it was easy for me to survey only my classes. Okay, which is why it's called a convenience sample. And then the last one, self-selected. So this is where people would volunteer. So basically, if we asked students to fill out a survey if they want to. Okay, so this is basically if you choose to do it. You choose to do this type of survey. Okay. All right. So now example 1, the officials of the National Football League want to know how the players feel about some proposed changes to the NFL rules, so they decide to ask a sample of about 100 players. This is asking us to classify each sample. So the officials choose the first 100 players who volunteer their opinions. So this is a self-selected sample because the players volunteer. So this is self-selected. I don't know what's going on with my pen, but it is not wanting to write today, y'all. The next one, the officials randomly choose 3 players from each of the 32 teams in the NFL. So this one would be stratified because the population is first divided into groups, the 32 teams, and then members are chosen from each group, okay? That's key right there, the each group part, okay? So this one is stratified. And then the last one, the officials have a computer-generated list of that 100 players from a database that includes all of the players in the NFL. So this one would be called simple random sample, because each player has an equal chance of being chosen. All right, let's see if you guys can do these three and then come back to me when you're done. The campaign staff for a state politician wants to know how voters in the state feel about a number of issues. So we're going to classify each of these samples. They call every 50th person on a list of registered voters in the state. This will be a systematic because it was every 50th person. So this is a systematic sample. The next one, they randomly select 100 voters from each county to call. This will be stratified because it was from each county, 100 people from each county, right? So that would be stratified sample. And then they ask every person who comes to the next campaign rally to fill out a survey. This would be convenience because they just happen to show up. Whoops, I spelled that wrong. I do that a lot. E-N-I-E-N-C-E. There we go. All right, so the sampling method chosen should consider accuracy and budget. Usually the more accurate samples are, the more expensive. Of course, the best would be a census, but where every individual in the population is a sample, that's usually just not feasible. So the most accurate is a census. Then we've got simple random, stratified, and cluster are very accurate, and then not very accurate are convenience and self-selected samples. So do y'all notice one missing here? Systematic, yeah. In systematics, I would say very accurate too, so we could put that under here. Okay? All right, so then example 2 says a high school has 552 freshmen, 495 sophomores, 449 juniors, 439 seniors enrolled. The student newspaper wants to take a survey of the school. Classify each sampling method, which is most accurate, which is least accurate. Explain your reasoning. So the first one here says randomly select 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors from the complete roster. So this is a stratified sample. If we randomly did those. Method B was randomly selecting 200 students from the complete roster. That's a simple random sample. And method C was choose every 10th student who enters the cafeteria at lunchtime. That's a systematic sample. So of these three, obviously this one, now let's go back because I'll show you all. This is the most accurate, right? This is the least accurate, okay? And they kind of move from there. So simple random is always going to be your most accurate, all right? So then we're talking about simple random would be the most accurate, systematic would be the least accurate, and stratified would be a little bit more accurate, okay? So a small town of newspapers wants to report on a public opinion about the new City Hall building. Classify each sampling method, which is the most accurate, which is the least accurate. Explain your reasoning. So it asks the readers to write in and give their opinion. So this would be, actually, why don't you guys do this and then answer and then come back and check with me. So this one's self-selected. And it would definitely be the least accurate, okay, of the two methods. And then survey the people who come to the next town meeting. That's going to be convenience. And this one would be more accurate than self-selected, okay? All right, so the margin of error of a random sample defines an interval centered in the sample percent in which the population percent is most likely to lie. And we're going to talk about what this means in just a second. So this is going to be margin of error. So for example, a polling organization conducts a survey to find out how voters plan to vote in an upcoming mayoral election. They report that 58% of the 1,000 voters in the survey plan to vote for Smith, and that the margin of error is plus or minus 3%. Okay? So what this means is the percentage of voters in the population who plan to vote for Smith is between 55 and 51. And the way that we get that is we take the 58%, and we're going to add and subtract 3 from it. So we would do 58 plus 3, or sorry, I'll start with minus. 58 minus 3, that would be 55, and 58 plus 3, and that would give me 61. So my interval is between 55 and 61. So example 3 says a survey of random sample of voters shows that 38% of the voters plan to vote for Gonzalez, 31 plan to vote for Chang, and 31 plan to vote for Harris. The survey has a margin of error, again, of plus or minus 3%. So does the survey clearly project the outcome of the voting? So what we're going to do here is we're going to subtract and add 3 to 38. So when we do that, we're going to get 35 to 41%. And we can put percent there too. Down here, we're going to get 28% to 34%. And again, we're going to get the same thing, 28% to 34%. So because there's no overlap in the interval, Gonzalez in the between the interval of Gonzalez and the intervals of Chang and Harris, we are pretty confident that Gonzalez is going to win. So it says down here, when would you not be able to clearly project the outcome? So for example, if we were to change, if for example, when we did this, this number had been 35, y'all, then we would have had overlap in the groups, okay? So that's what it's talking about here when it says, when would you not be able to clearly project the outcome? So what we need to say here is if there's overlap, if there is overlap, then what? Then the results are inconclusive. Move this. Clue, yeah, it'd be good if I could spell right. Inconclusive. Inconclusive. Okay? So if there's overlap, that's the key right there, y'all. If there's overlap in our intervals, then that's when we have that we can't say who's actually going to win. All right, so let's do this. You try, come back to me when you're done. All right, so on this one, we've got, according to the survey of a random sample of city voters, 40% of the voters vote for Poe. So we're going to do 42, and then it's got plus or minus 7. And 58 voted for Nagel. So that's going to be plus or minus 7. So that's going to be equal to, when we subtract 7, we get 35% to, and then we add 7, we get 49%. Okay. Then over here, we subtract 7, we get 51% to, and we add 7, that's 65%. So do you see any overlap in these? So what you really want to look at is here. So do you see this 49 and this 51? Well, they don't overlap, because if this one on the left said 52 and the one on the right said 51, then yes, there would be overlap. So the answer, so then it says, does the survey clearly project the outcome for the voting? The answer is yes. And the reason is because there's no overlap. Okay, so who was it that we projected is going to win? This person right here, right? Okay.